This video is an excerpt from the ϕPPL Programming Language Lecture Series. Copyright 2013, Technoventure Incorporated. Bitwise Boolean Operators. Perhaps the most fundamental of all of the operators are the Boolean operators. These should be easier to understand than the arithmetic operators, but in school we are taught so little about them that a lot of people get confused when talking about them. They operate on only a single or pair of bits at a time. But before we discuss Boolean operators, let's first review what Boolean values are. The word bit is short for binary digit. A bit can only have one of two states, 0 or 1. Depending on how you interpret these values, they can correspond to off and on, left and right, south and north, or any number of opposite states. Most modern programming languages support 4 basic Boolean operators. These are not, and, or, and exclusive or. This last one is often referred to as XOR. Not is considered to be a unary operator because it only takes one operand. The other 3 Boolean operators are considered to be binary operators, not because they operate on numbers that are represented in radix 2, but because each operator takes 2 operands. Standard algebraic notation puts the operator between its 2 operands. A truth table describes how each of these operators works. All possible input values are listed in the heading along the top of the table for unary operators. For binary operators, input values for the first operand are listed in the column headings along the top, and input values for the second operand are listed in the row headings along the left side of the table. The outputs or results of the operation are shown in the interior of the table. Since not is a unary operator, its truth table has only one input variable. If the input value is 0, the output value is 1. Otherwise, if the input value is 1, then the output value is 0. For the AND, OR, and XOR operators, we have 2 input variables. For the AND operation, if either input is 0, then the output value is 0. Only if both inputs are 1, then the output will be 1. For the OR operation, if either input is a 1, then the output value is 1. Only if both input values are 0 will the output be 0. For the XOR operation, if the inputs are the same, then the output is 0. If the 2 inputs are different, then the output value is 1. The C programming language supports 4 basic Boolean operators. They are called complement, AND, OR, and XOR. There is a unary operator in C called the NOT operator. That one, though, belongs to another group of operators called the logical Boolean operators. We will talk about those in a future tutorial. We call the unary bitwise Boolean operator complement so that we don't confuse the two. In C, the 4 basic Boolean operators are represented by single characters. The tilde means complement. The ampersand represents AND. The unbroken vertical bar represents OR, and the caret represents XOR. In C, you cannot declare single-bit values. All data types are multi-bit values. When you apply these operators, each bit position within a multi-bit value becomes an independent operand on its own. Boolean operations are done in parallel on 1 or 2 multi-bit operands depending on whether the operator is unary or binary. The result of each bit operation ends up in the corresponding bit position within a multi-bit result value. Because these operators work on multiple bit positions in parallel, they are called the bitwise Boolean operators. The ϕPPL programming language supports these 4 Boolean operations plus one more. It is called the same operator. The truth table for the same operation is the identity table. The output has the same value as the input. In phi, the 2 unary operators follow their operands instead of preceding them. The reason is so that your source code will look more like what you were taught in math class in school. So instead of saying complement A as you would in C, you say A complement, as the mathematicians do. It looks like writing A prime where the Unicode accent mark is the complement operator. The ASCII grave mark slants the other way, and it represents the same operator. The phi and operator then is the ASCII ampersand as it is in C. Likewise, the unbroken vertical bar is the phi OR operator as it is in C. For the XOR operator, using a caret will not do because this is the pointer indirection operator in phi. Instead, the percent symbol is the XOR operator when writing phi source code. Since the percent symbol looks much like the X in XOR, this should be enough for you to remember what it means in phi. For those of you who prefer the Boolean operator symbols that you learned in school, you can use the Unicode AND operator symbol or the Unicode OR operator symbol. These are discouraged because the OR looks too much like a capital V, and an AND looks a lot like a capital A with a crossbar removed. If you use the ampersand for AND, then you should be consistent and use the vertical bar for OR. Conversely, if you use the Unicode AND for the AND operator, then you should use the Unicode OR operator for the OR operator. Don't mix your metaphors, as they say in literature. As yet, phi does not provide an alternative symbol for the XOR operator because it has not been adequately standardized in Unicode. We have one more related topic to talk about, and that is operator precedence. I will compare C and phi side by side in the following example. The relative operator precedences for the bitwise Boolean operators are the same for both programming languages. However, you should keep in mind that the relative operator precedences between certain operator groups are slightly changed. Now for our code example. On top, we have an assignment statement in C, while we have its equivalent in phi below. Among the bitwise Boolean operators, the unary operators have highest precedence, so they happen first. In our example, this is where B is complemented. I threw in the same operator for D just for grins. Next to be evaluated are the OR and XOR operators that have the same precedence. The AND has the lowest precedence of all the bitwise Boolean operators, so it happens after the others are complete. Finally, the assignment operator has the lowest precedence of all, and so the last thing to happen is the assignment of the final result to A.